Got another video on comparing functions in SQL, Python, and R. Today I want to talk about joins. So first off, why do we use joins? Here's the classic example in a normalized database. Uh, it's usually broken down into tables specific to different parts of the business. Say for sales, you'd have order table, a product table, a customer table, an employee table, so on and so forth. Break them down, use SQL to query them or whatever software you wish, bring them back together. To do that, you need a join. So I have order ID, product ID, and quantity on my order table. I have product name, product ID, and product price on my products table, but my price and quantity columns are in different tables, and I need to get an order total. I can't get that. I can only get price from one table and quantity from the other. To get the order total, I need to join them. So we're going to start in Pandas today. Uh, Decided to start just doing all these in Colab, Google Colab instead of VS Code or anywhere else because I just love Colab for the text, markdown, ease of getting it onto my GitHub, etc. So, and this will all be in my GitHub repository, the link in the description. So joins and pandas, uh, you have to install the necessary packages. Pandas is import pandas as PD, import numpy as NP, and we just run that. If you're doing machine learning, you can run them on a GPU free of charge. This is Colab's just great. Now I need to make some data frames, some tables. So I'll make a dictionary for order list. Order ID is a list of 1, 2, 3, 4, 5. Product ID is a list of A100, B100, C100, A100, C100. And quantity is a list 54436. So now I turn that into a data frame. My orders equals pd.dataframe order list. And I'll run that, show you my orders. Nice little table. Looks great in Colab and the Jupyter Notebook. Do the same for product list. Again, I created a dictionary. The keys are the column names. The values are the values. The list values are the values. So product list, my products equals pd.dataframe product list. Let's look at that. Another nice little table here showing the product name, IDs, and prices. You'll notice black balloon has not been sold. Keep that in mind. So for an inner join, um, they asked you to find the order total for each order, but price and quantity are on different tables. You can use an inner join. See all entries from the left table, my product, that have corresponding entries in the right table, my orders. Keep in mind which one's the left table and which one's the right at all times. To perform the join, we need a key column to join on. Well, key column would be something that's the same in both tables. I've made this obvious. Column names are exactly the same, and so are the values. So we want to join on product ID. You may find this a little harder to figure out in the real world, but I made it simple for this one. So in our case, it is product ID. Pandas, for the type of joins we're using, we're going to use merge. Join in Pandas is primary for index joining. Merge is more versatile. It allows for more column-based joins using keys. So generally, you're going to want to use merge for something like this. Perform an inner join on the product ID column. Inner is the default for merge, so you don't have to put the how argument here in this case, but we will. So result of inner join equals pd pandas dot merge my products with my orders. Merge them on the product ID column. How we want to merge them is inner. And then we want to view the result. Result enter. So now I have name, ID, price, order ID, quantity from everything that was on the left table and its corresponding entries on the right table. So this solves our problem, and now we can add a column to data frame for order total using price times quantity. They're all in the same table. Let's do that. Result enter order total, that's a new column, equals result enter product price times result enter quantity. Show result enter. So now we have our order total, 995, 597, etc. So that's inner join in Pandas. Left join, well, they asked you to find all the orders, balloon types, and prices, even if the type of balloon has never been ordered. So it didn't do anything with black balloon from my products table because no one's ever ordered it. Therefore, it doesn't have a corresponding right entry. But left join doesn't care. So perform a left join, result left equals pd dot merge my products, my orders on, again, product ID, but change the how to left. And we'll view that. So now it's got everything. And when a black balloon's there, it'll drop a NaN, not a number for order ID and quantity because they didn't exist. It's never been ordered. But now we know we have black balloons in stock, even though they've never been ordered. That's the left join. Right join is the opposite of left, and I don't really use it. I just switch the right table to the left because I think better that way. But here it is for demonstration purposes, and in this our case here, it's equivalent to an inner join. You know, price and quantity, it's all there. If you had something on the right that wasn't on the left, of course it would appear. Uh, Again, I just switch tables. The outer join, you're asked to make a table with all the information from both tables, and so that'll give us with all the information from both tables. So you change the how argument to outer and repeat result outer. So it's got everything, both tables, again, NaNs when there's nothing there. And I have one last one for pandas cross join. And I have one last join, cross join. We were asked to get a list of all possible balloon colors and size combinations, balloon color and size combinations, even if we didn't sell them. Uh, Cross join gives you the Cartesian product between two data frames. Combination of every row from one table with every row from the other table. And to use my current data frame would get a little confusing, so we're going to create a new one real quick. Balloon colors, red, blue, and green. PD data frame, balloons. There we go. Simple data frame, red, blue, green. Balloon sizes, small, medium, large. Same deal. PD data frame, dictionary. All right. Then we have red, blue, and green in color, small, medium, large in size. Color combinations equals PD.merge balloons and sizes. How we merge them equals cross. So, okay. So now you can get a red small, red medium, red large, blue small, blue medium, blue large, green small, green medium, green large. So if we weren't selling something, this would give us a list of everything we could possibly sell, and then we could pick from that. And that is cross join. So now let's go to SQL. We're going to run the same exercises. Uh, so I've got DBO my orders and DBO my products. And start with enter. You're asked to find the order total for each order, but price and quantity are on different tables. Let's just look at the tables. Okay, same as in pandas. Enter join all from the left that have corresponding on the right. So we say, in this case, it equals a lot different. We select our column names from both tables. Then the MPs and the MOs, I usually add them last. So I would type out select all the column names you want from both tables. Then from the left table, give it an alias. My products is MP. Then inner join. You don't have to put join inner default. If you type join, it defaults to inner. In this case, I will, and then you join it with the other table, which is my orders MO. Like I said, you can just put join on mp.product.id, alias of product ID equals mo.product ID. And then go back and put your aliases in front of your column headers so it knows which table. You've got to tell SQL which table you're picking from. So I want to select from my products, the product ID, name, and price, and from my orders, the order ID and quantity. I want to select from my products MP join to my orders MO on product ID equals product ID MP and MO. So run that. Okay, now we've got order quantity and price on the same table, so we could drop in a conditional column. Look here, I have this commented out. I'm just going to paste it, copy and paste it right here. If we run this again, get a nice order total quantity, and yes, we did. So that's the inner join. Left side before, you want to find all the price orders, types, and prices, even if the balloon has never been ordered. So we would use the left join. So all it's the same. You just change the join to left join. And here we are with the black balloon shows up now. Okay, right join. Like I said, I don't use it. I switch my table order because I think it's better that way, but here's a right join, and it's probably going to end up looking like an inner in this case. Okay, outer table with all the information from both tables. Well, outer is full SQL, and you don't need to select your column names because you want everything. So select star for my products MP, full join my orders MO on mp.product ID equals mo.product ID. This should give you everything. Okay, and we have black has no order ID, no product ID, no quantity, but everything is there. Cross join, we're going to do another simplified data frame. Since I've been running these, I need to drop the tables if they're already there and then recreate them. So I'm going to create a table called balloons with color, varchar, insert red, blue, and green, and also one for sizes and insert small, medium, and large. This script will be in my GitHub repository. You can copy it now or check it out there. But let me execute that. Uh, you create the tables, 3 rows were affected. Let's just look at them. Color table, red, blue, green, size table, small, medium, large. So select balloon.color, s.size from balloons B, cross join sizes S. And there's our list of all possible color and size combinations. So SQL, a lot different, but not too bad. Let's try the R. In R Studio, great IDE for R, my preferred. And to run it, you need to do library tidyverse, get the package installed, and then we're going to create the tables. So it's a table. My products, same table as in the other two languages. There it is. Product name, price, and ID. I'm going to create my orders table. Table is just a simplified, stupid form of a data frame that you can easily manipulate. order ID, product ID, quantity in my orders. Okay, get the total order, but total order total, but price and quantity are on different tables. So result enter. In the tidyverse, the joins are type of join underscore join. So result enter is equal to enter join my products, my orders by equals product ID, the join column. Let's see that. Okay, we got them on the same table. Now we get our order table in tidyverse. You add a column with mutate. So result enter pipe in mutate order total equals product price times quantity. And there's our order total. Beautiful. Have the left find all balloon types, prices, even if they don't have any orders. So left join my products, my orders by equals product ID and show result left. There we go. The black balloon is now on there. Right join, again, equivalent to inner join. Don't use it, but here it is for demo purposes. So right, there you go. There are two joins before we get to cross join in R that do not appear in SQL and Pandas. They are anti and semi joins. They're not native. You can create them using subqueries in SQL and cosine custom functions in Pandas if you want, but there aren't no native functions. Task, get only unique products ordered and their prices. So I don't want the ones that weren't ordered. See right, only that have corresponding left. See products that have been ordered. I don't want the ones that haven't been ordered. So I can semi-join by product ID. And that's just going to show me uh, products that have been ordered and their prices. Now it's different from the inner join because in inner we got every order, so there's duplicates. We didn't care about the order ID. We just wanted to know the unique product IDs that have been ordered and their price. So we did a semi. It just has A100, B100, and their prices. Doesn't have anything to do with the order. So that's a semi. Now anti, get a name product price of products with no orders only. So I want to do a left join to get the black balloon, but I don't want anything else. I just want the black balloon. When I did a left up here, where's my left? I got everything. I don't want to know everything. I just want to know that one product that hadn't been sold. I don't care about the other ones that have been sold. My goal is to find the one that hasn't been sold and its price. So I can do an anti-join. D100 black balloon, $3.99. So that's an anti-join. So those are just kind of filtering out the left and enters to only what you wanted to see. So cross join is a little different, has a little different syntax. It does return the Cartesian product. First table is paired with every row of the second table. It doesn't have a dplyr function. It does have a tidyr function, all included in the tidyverse, and that is crossing. So let's create a couple data frames. Balloons. I love when it turns different colors when you write them out. There's a table of colors. See red, blue, green. Sizes, a table of sizes, small, medium, large. Look at those. There's balloons. There's sizes. So if I wanted to see all color size combinations, in this case, I would say color combinations is equal to balloons. Pipe balloons into the tidyr function crossing, and cross join it with the sizes. So let's see that and look at it. And there it is, blue, large, medium, small, green, large, medium, small, red, large, medium, small. Our cross join. So that is joins. So here's a little cheat sheet I made up for you in closing. Enter, merge how equals enter, compare between the different ones. I think for me, the pandas in R are a little more straightforward, and you can do a little more with R. I probably overall prefer Python Pandas merge function. That's just personal preference. You can pick, now that I've shown you how to use them, you can pick and choose or know how to do them in whichever language you want. And that is it for the join video. I hope you liked it. If you did, please like and subscribe, and I will see you next time. Thanks, everybody.